Hi everyone, my name is Alex Denny and I'm an assistant instructor with the BZAC Club Eden Divers. I put this presentation together because I was helping my other half with her sports diver training, and it seemed that the concepts of partial pressures and maximum operating depth are a little bit hard to get the head around, so I put this presentation together which I hope helps people. I want to start just with a quick reminder of depth and pressure and how it all works. And just a reminder that at the surface we've got one atmosphere, which is one atmospheric pressure that we also call 1 bar. As you get deeper, the pressure increases by 1 bar every 10 meters. So when we're down at 20 meters, it's 3 atmospheres, and when we're down at 30 meters, it's 4 atmospheres. So nice and simple like that. But it's quite important as a concept for what we're going to move on to. So partial pressures, what actually is it? Well, the way I like to think of it is it's just how much of each component gas that you're actually breathing within a nitrox mix. And you might remember that breathing air is 21% oxygen and it's 79% nitrogen, but we can increase the level of oxygen in a mix to prevent or decrease the risk of decompression sickness and allow your no stop times to be a bit longer. So let's start with a nice simple gas mix, nitrox mix of 25% oxygen and 75% nitrogen. So that's ups the oxygen content by 4%. Now 25% of 1 bar, so at the surface, we can call 0.25 bar. So your partial pressure of oxygen is 0.25. Why does it matter? Well, we're going to take this and we're going to compress it and stick it all into our diving cylinder, and we're going to breathe it out later on. So we start our dive and we go down 10 meters is 2 bar, 20 meters 3 bar, 30 meters is 4 bar. So we're going to end up breathing oxygen and indeed the nitrogen at 4 times the original atmospheric pressure. So what we're going to do literally is just add up the 4 0.25s that we've just come up with. So 0.25, half, 0.751, and we end up with 1 bar partial pressure of oxygen and 3 bar partial pressure of nitrogen. And as we can see here, that adds up 1 plus 3 equals 4, which is the 4 bar for the depth that our little diver on the left hand side has reached. So why does it actually all matter? Well, we've got this little thing called central nervous system toxicity, which is going to help us define a maximum operating depth. When we breathe air, the red cells in our blood absorb oxygen, and our bodies need this oxygen to extract energy from our food. Otherwise, we all get weak and feeble. Feek and weeble, as my dad used to say. If our bodies absorb too much oxygen, though, it becomes toxic. It affects our central nervous system, and the higher the partial pressure of oxygen, the more of it we're going to absorb and more quickly. This can cause blackouts and convulsions like this diver down here. So we've got a maximum recommended partial pressure of oxygen of 1.4 bar, but that will be different. It will be reached at different depths depending on the gas. So let's use an example for a very common gas mix. So let's ask ourselves a similar question: is it safe to do a dive to 30 meters on nitrox 32? And nitrox 32 is a mixture of 32% oxygen and 68% nitrogen. So the 32% nitrox mix, which we know at surface pressure is 0.32 bar partial pressure of oxygen, because it's the same as calculations we did earlier. So let's have a look at this. Our diver is going to go down 10 meters, 20 meters, 30 meters, and at 30 meters we're going to breathe this in at 4 bar. So it's quite simple. We're going to take 0.32, add them all together, times 4 times, and we'll come up with a partial pressure of oxygen now of 1.28 bar. So 1.28 bar is obviously below 1.4 bar, and we can say that the gas mix is safe to breathe in at 30 meters. Go a little bit deeper though. What about 40 meters? I think you're probably picking up on a theme here. So we're going to now breathe, so 10 meters, 20 meters, 30 meters, 40 meters, we're at 5 bar. So this time our calculation is going to be 0.32 times 5. So you can see them all there. And 0.32 times 5 is a partial oxygen pressure of 1.6. So partial pressure of oxygen is above 1.4. The gas mix is not safe, and our little diver is convulsing again. So how do you actually get to the maximum operating depth of nitrox 32? We know you can't. You can dive quite happily to 30 meters. You can't dive to 40 meters. So somewhere in between these two, we've got the MOD. Well, remind ourselves again, the maximum PPO2 we want is 1.4 bar. We need to convert this into a depth. We know that the total surface, the surface total pressure is 1 bar and the PPO2 is 0.32. How many 0.32s fit into 1.4? So last time we were multiplying. This time we're going to do a division. And we can see here 1.4 divided by 0.32 is 4.37. If you're doing you can do that on a calculator, and it's the easiest way of doing these calculations. It's actually 4.375, but because we want to be prudent, safe divers, we always round down when you've got odd little numbers like that. 4.37 bar, we then want to convert that into a depth. So we're going to go down 30 meters would be 4 bar, so we're above that, but you can see it's always been linear. So we're going to knock off the first surface bar, the first 10 meters, and we'll then come up with 4.37 bar is 33.7 meters maximum operating depth, and that is reached simply by doing 1.4 divided by the nitrox mix we're at. You can actually type it into a calculator using as 1.4 divided by 32%, and it should give you the right answer. You can see as well in the pie chart on the far left hand side that we can get from that the partial pressure of nitrogen being 2.97 bar, which is useful if you are trying to do calculations for your decompression times. There's a much simpler way as well of doing these calculations if you don't have the calculator. We've got tables, and they're in the VSAT guide, the 88, so in fact not the 88 tables, sorry, the nitrox tables. And you can just look them up. So I'm going to look up where 32% comes on the top row of this. What's my maximum PPO2? 1.4. You will see that they're written out for different PPO2s, because while 1.4 is the standard recommended depth, for some technical divers and things, there are differences. And then we're just going to kind of refer across the table, look down, and we'll find that comes out as 33.7, which is exactly what our calculation gave us. So that's how it all works. And if you've got any questions, please just let us know.